this is the modern physics topic, this section is called the classification of matter. This section is based upon one of your reference tables. Open up to the page that has energy level diagrams, hydrogen and mercury on top, and on the lower left corner, the reference table called Classification of Matter. Now, I will also be referring to the reference table which we looked at in the previous section called Particles of the Standard Model, the quarks and the leptons. So, I will be referring to both of these reference tables down at the bottom of this page. All right, so let's go. Now, one of the things that I want to show you is all of the information that you can read directly from the chart on the lower left, classification of matter. In other words, facts that you don't have to memorize because they're right on the chart. I'll tell you when they're on the chart, and I'll tell you when it's something that you have to memorize. If we look at the chart, we see that all matter can be broken down into either hadrons or leptons. All right, let's just take a look at an overview of the chart, and then we'll get more specific. The chart shows that all matter consists of either hadrons or leptons. Perhaps you recall that we talked about leptons in the previous section. Leptons, like electrons, the muon, and the tau particle, which are found down here, as well as all the neutrinos. Now, hadrons are further subdivided, look right on the chart, into baryons and mesons. Now, you can also see clearly from the chart that baryons are composed of 3 quarks each. So every baryon is composed of 3 quarks. And every meson, according to the chart, is composed of a quark and an anti-quark. All right? So we get all of this information straight from the chart. We don't have to memorize anything. All right, now let's look at some more information that we should know about hadrons, leptons, baryons, and mesons. First of all, I'd like you to remember that hadrons are heavy. Hadrons are heavy. H, and leptons are light. Now, why is this? Well, one rudimentary explanation would be that hadrons are made out of smaller particles called quarks and antiquarks. So the hadrons would be heavier because they're made out of smaller basic particles, smaller elementary particles. Leptons are light because they are themselves elementary particles. They are not made out of any smaller particles. And again, in general, hadrons are heavy, leptons are light. Some examples of hadrons would be the proton and the neutron. A good example of a lepton would be the electron. And you know that protons and neutrons are both much, much heavier than electrons. So again, in general, hadrons are heavy, leptons are light. Keep that in mind. That is not shown on the chart directly. All right, now, we stated earlier, and you can see from the chart, that hadrons are subdivided into baryons and mesons. We said that baryons, again from the chart, hadrons are divided into baryons and mesons, and baryons are each made out of 3 quarks. 2 good examples of baryons are our friend, the proton and the neutron. Let's see how protons and neutrons are made out of 3 quarks each. All right, our friend the proton is made out of 3 quarks. 2 up quarks, U, U, and a down quark, D. Now, let's add up the total charge of 2 up quarks and a down quark and see if we get the correct charge that we know to be true for a proton. We should get positive 1 E, or 1.6 times 10 to the negative 19 coulombs. Let's see. An up quark is positive 2/3 E. Another up quark, another positive 2/3 E. And finally, a down quark, which is negative 1/3 E. I'm sorry. Do you remember that all of these quark charges are listed right on the reference tables? Up quarks, down quarks, these are their charges listed right on the reference tables. Nothing to memorize. Let's add this up. Positive 2/3 and positive 2/3 is 4/3. 4/3 E minus 1/3 E gives us 3/3 E. Okay, so what we have so far, positive 3/3 E. Well, that's positive 1 E. And that's correct. That is the charge of a proton. Now, you have to memorize that a proton is made of 2 up quarks and a down quark. But if you forget, you can double check by making sure that the charges of 2 up quarks and a down quark add up to positive 1, the charge of a proton. All right, now let's try the neutron. And remember, these are all examples of baryons. Baryons which consist of 3 quarks each. Okay, our friend the neutron is made up of an up quark and 2 down quarks. Let's add up the charges for this trio and make sure that it comes out neutral, as a neutron has to be. An up quark, positive 2/3 E. A down quark, negative 1/3 E. Another down quark, negative 1/3 E. Positive 2/3 minus 1/3 minus another third is going to be 0 E, or 0. The charge of a neutron is 0. So 1 up quark and 2 down quarks completely cancel out in their charges, and you get a charge of 0 for the neutron. So again, you must memorize this. The Regents exam does expect you to memorize what a proton is made out of and what a neutron is made out of. All right, let's try some other baryons that you don't have to memorize. Let's take a look at a baryon called a sigma. Now, there are different types of sigma. All right, this one particular sigma, let's see what his total charge is going to come out to. All right, this sigma particle is 2 up quarks and a strange quark. Up, up, strange. Let's see what the total charge of this sigma comes out to. The up quark, positive 2/3 E. Another up quark, positive 2/3 E. And a strange quark, negative 1/3 E. Wow, this one's just like a proton. Positive 2/3 plus 2/3 is 4/3, minus 1/3 is again 3/3, positive 3/3, or positive 1 E, just like a proton. So this particular sigma is a sigma positive. He's got the same charge as a proton. Let's look at another baryon. Right, there are dozens and dozens, probably hundreds of these particles. Remember, the only 2 that you have to memorize are the proton and the neutron. I'm giving you the others just as examples. All right, here's another example called a charmed sigma. A charmed sigma. And let's see what the total of a charmed sigma comes out to. All right, we've got an up quark, and a charm quark. Let's add it all up and see what the total charge is. Positive 2/3 E, positive 2/3 E, and the charm quark is also positive 2/3 E. Look it up on your reference table. Add these all up. 2 plus 2 plus 2/3 would be positive 6/3. That's positive 2 E. So, the total charge of the charmed sigma is positive 2 E. All right, so we've seen a couple different examples. And one of the things that I would like to point out at this time is that there are only certain charges that baryons can have. The total charges that we've seen so far, positive 2, positive 1, and 0. And you can see that you can also get a negative 1 or a negative 2 if you play around by mixing different quarks. All right, so these are the only possible charges for baryons. Positive 2, positive 1, 0, negative 1, and negative 2. All right, quick little review. We have matter broken into hadrons, which are heavy, like protons and neutrons, and leptons, which are light. Hadrons are further subdivided into baryons, which are composed of 3 quarks each, and mesons, which are composed of a quark and an antiquark. We'll be talking about the mesons in just a moment. Some examples of baryons that you must memorize are the proton, which is UUD, and the neutron, which is UDD. Now, let's talk about mesons. Let's build some mesons. Looking back at the chart again, we are reminded that mesons are composed of a quark and an antiquark. Now, it's quite likely that you've never heard of some of these mesons before. I'm going to start with a meson called a pion. And this particular pion is going to be positive. In a moment, I'll also show you a neutral pion. But the first pion that I show you will be positive. Now, a pion is composed of 1 up quark and 1 down antiquark. Again, 1 up quark and 1 down antiquark. Remember that a meson, every meson, is composed of a quark and an antiquark. Now let's figure out the charge on this meson, this specific meson called a pion, a positive pion. The up quark, we look on the chart, is positive 2/3 E. Now, a down quark is negative 1/3, but this is an antiquark, a down antiquark, so change the sign. This is positive 1/3 instead of negative 1/3. Add it all up, we get positive 3/3. So the charge of this meson, this pion, is positive 1E. All right, now let's construct a neutral pion. Okay, there are different kinds of pions. And you will find in general that for many of the mesons, there's a positive version, a neutral version, possibly a negative version, etc. Usually pions have siblings, so to speak. Not identical twins, all right, but siblings. So now we have a neutral pion. And a neutral pion consists of 1 up quark and 1 up antiquark. 1 up quark and 1 up antiquark. You can see what's going to happen here. The up quark from the chart, just read the chart, has a charge of positive 2/3 E. The up antiquark would be negative 2/3 E. Of course, these cancel out exactly, and we end up with a charge of 0. So here's another particle besides the neutron that has a 0 charge. All right, let's try some other mesons. Let's do a kaon. All right, a kaon consists of one quark and one strange antiquark. A kaon consists of one up quark and one strange antiquark. All right, let's add this up. An up quark is positive 2/3 e. A strange antiquark, now a strange quark is negative 1/3, so the strange antiquark would be positive 1/3. And again, we have a positive 1 charge for the kaon. So this is a positive kaon. There could very well be a neutral kaon, a negative kaon. All right, again, mesons often have partners who have different charges because of their different quark or antiquark makeups. All right, now, let's do a theoretical meson here. All right, I'm not going to give this one a name. We're just going to come up with a meson that is theoretically possible. And we have here our theoretical meson. Because we'd like to see the one last charge that mesons can have. Let's try a down quark and an anti-up. All right, a down quark and an anti-up quark. All right. The down quark, look at the chart, is negative 1/3 e. The up quark is positive 2/3. So the anti-quark, the up anti-quark, would be negative 2/3. So what does this total? Negative 3/3, or negative 1e. All right, so we have here a meson with a charge of negative 1. So to sum up, the possible charges for mesons would be either positive 1, 0, or negative 1. Those are the possible charges for mesons given the quarks that we have on hand in the universe. All right, what we've looked at here is the chart entitled Classification of Matter. We see that matter is broken up into hadrons, which are heavy, and leptons, which are light. Think of some examples right away, some examples of hadrons, protons, and neutrons, and also our new friends, the pions and the kaons. Now, leptons are light. A good example of a lepton is an electron, but keep in mind that there are 6 leptons listed on the other chart, particles of the Standard Model. Now, our hadrons, our heavy particles, are broken down further into baryons, which consist of 3 quarks, good examples being the proton and the neutron. You have to memorize that a proton is made of 2 up quarks and a down quark. UUD is a proton. If you forget, just add them up and make sure they come out to positive 1e, some combination of ups and downs. The neutron, again, some combination of ups and downs that comes out to 0 would be UDD. And those would be the quarks in a neutron. They total up to 0 charge. Our friends, the mesons, are made of a quark and an antiquark. You don't have to memorize these, but it might be nice to have a couple of examples on hand, like our new friends, the pion and the kaon. I will see you in the next section.